Right, okay, so this is just to recap the multiplying standard form. Okay, so we've got two numbers, both of them are in standard form. How do I know these numbers in standard form? So it's just a check to see if you remember what standard form is. Good, but could it be any number times 10 to the power of something?
I think it has to be a single digit, and it has to, it has to be a single digit.
These aren't single digits. Be careful how you say that.
Well, there has to be one digit, but just one digit before the decimal point. And then
Good, so that makes it a number between what?
1 and 10.
Good girl.
No,
Okay.
1 and 9. Because you
No,
can't.
it has to be between 1 and 10.
Yeah.
Yes, totally. Okay, so this number, remember, so this part of it has to be between 1 and 10. Okay, so it can't be 0 point something, it can't be 12 point something.
It can't be 10.
Someone said initially it just has to have one digit. Yes, so it's got to be 1 between 1 and 10, and then multiply by 10 to the power. Remember, this power here can be positive or negative. Okay, so that's a nice little recap about general things about standard form.
What if you have like a negative power times a positive power?
Well, we can talk
We
about
have to
that.
add those together, right?
Yes, yeah.
Negative power?
Yeah, well, we'll talk about that in a second. Okay, so these two numbers are in both standard form, yes? They're in brackets, and there's no sign in between them. So when things are in brackets, there's no sign in between them. What does it tell us we're doing to them, Kaya? Good, it means you're multiplying. So, obviously the title gives that away, but in a test or any questions, you're not necessarily going to, it's not going to say multiplying in standard form, okay? So, we're multiplying these together. We talked about this the other day. So, if we've got 2.1 multiplied by 10 to the 8, multiplied by 3.2 multiplied by 10 to the 4, does the order in which we do this multiplication matter? No, okay? So I'm going to choose to focus on these numbers here to start with. Okay? So we're going to multiply those numbers together. Now, if you recall, we did this, I think the board wasn't working, was it? So we haven't got a record of this, have we? We just did it on the board. So if we were doing 2.1 multiplied by 3.2, you have your calculators, okay? So you can just chuck it in your calculators and we get 6.72. If for any reason we need to do this without a calculator, if you recall, we pretend that we are multiplying 21 multiplied by 32. To do that, we focus on the 2 to start with, and we multiply the 2 multiplied by 1, 2 multiplied by 2. And then what do we do when we come to our second digit and y? That's it. Why do we do that? Good, because this represents 32, not just 3. Okay? So we have to have the 0 in. So then we're going to do 3 multiplied by 1, 3 multiplied by 2. And what do we do with these numbers for Sika? We add them together. So that's a 2, a 7, and a 6. Now we have to decide where our decimal point goes. Remember, there's two different ways of thinking about this. Sarah, what's one of the ways?
What I do is I have the decimal point, and the 2.1 is the number behind it.
Yep.
And I put it to like so that means there's going to be 2 spaces, so you get 2, and give you 6.
Lovely. So because in total in the question there are 2 digits after the decimal point, we have to move across 2 places. What was the other method that I suggested the other day?
I'm not sure if this is a little bit sentimental. Well, it has to be lower than 10. So,
Or it doesn't have to be, but look at these numbers initially. So what is this number? Just as the question, 2.1, yes? What's this number? So what's this number approximately? 2, and this is approximately. And what's 2 multiplied by 3? 6. Okay? So our decimal point has to go here. It's not going to go here or here, because otherwise it's too big. If it was here, it's too small. Okay? So remember that's your other check. Alright, so we've got the answer. As I said, you've probably got your calculators to help you with that anyway. Now, we now have to sort out these parts. So we've got 10 to the power 8 multiplied by 10 to the power 4. I can't remember remember if we had really done this? Do we remember that when we have, if we have 10 to the power something multiplied by 10 to the power something, we add these powers?
Yeah.
We did learn that, didn't we?
Yes. Yes, we did. I remember learning it. We just didn't talk about if there was negative parts.
So if we've got 10 to the power 8 multiplied by 10 to the power 4, what happens is our base doesn't change. Okay, so our base is going to stay as 10. And what we do with these digits is that we add them. So we're doing 8 plus 4, which gives us 12. Okay, so 10 to the power 8 multiplied by 10 to the power 4 will equal 10 to the power 12. Now, this is a side step because this is not the question, so don't get confused. But Abby said to me, what happens if one of these numbers is negative? Well, the rule still applies. So if we had 10 to the power negative 3 multiplied by 10 to the power 5, you would still add your powers. So you would have negative 3 plus 5. What's negative 3 plus 5? What? 2. So it would be 10 to the power 2. Okay? So the rule still applies. You just add your powers. You have another question?
Yes. If they're both negative numbers, it would be a positive, right?
No, sweetheart, because a negative number, when we're adding numbers, remember if the negatives is where you start off. So if it was 10 to the power negative 3 multiplied by 10 to the power negative 2, we're going to do negative 3 plus negative 2. So we're starting at negative 3 on the number line, and we're adding on negative 2. In other words, we're taking away 2 more. So we end up at negative 5. What you're getting confused with is, remember, when we multiply integers. So if you had negative 3 multiplied by negative 2, then the answer would be positive 6 because they are both negative values. Okay? So for adding and subtracting, it's your starting point, and then are you going to go left or right from that starting point? Okay?
Do you know if we're going to
You will be able to use your calculator.
Yeah.
Yeah, totally will be able to find. Okay, so then we're going to just put all our bits together. So we had our 6.72 multiplied by 10 to the power 12. So that's that question there. It was all filled in. And then we had some examples, some more examples. Now I said these ones you could do straight into your calculator. But let's have a little think about it. Let's try and do these quickly, even if you have done them on the calculator. So here I'm going to focus on the 2 multiplied by the 4. Which gives me 8. And then I've got 10 to the 3 multiplied by 10 to the 4, which gives me 10 to the 7. So then that's going to be 8 multiplied by 10 to the 7. Okay? So I know, so lots of you just went straight to this. Now, remember your calculator. So we did go through the calculator buttons, didn't we? And I got you to write it here. Let's see if I can find my calc. Oh, that's okay.
Just type it in the search bar on your computer.
Oh, actually, I think, do you know what? I think I've lost it. I think I lost it when I had it. No, okay. Yeah. Alright, so remember on your calculator, okay, so the screen's up here. Down here in the middle, at the bottom, there is a button that says multiply by 10 to the x. Okay, so that's the button that you would use to use standard form. So if you wanted to enter 3.7 multiplied by 10 to the x into your calculator, you would type 3.7 and then you would use this button and then just type the number, let's say 8. Then you would just type the power there, okay? So if you wanted 3.7 times 10 to the 8, you would put 3.7, press that button, and then 8. It just means you don't have to type in multiply by 10 to the power. Okay? So that's I'm sorry?
So was that on the last page? No.
Yeah, so I remember I just got you to tell yourselves how to use your
I thought that was
calculator.
on this page.
Alright, so then this one here, going back to this one here, we've got 3 multiplied by 10 to the 5, 2 multiplied by 10 to the 6. So the first step would be 3 times 2. And then we would have 10 to the 5 multiplied by 10 to the 6, which gives us 10 to the 11, which means our answer is 6 multiplied by 10 to the 11. We get 10 to the power 11. Okay, so hopefully we're all getting these. You said wait. You didn't do these last lessons, Asika? Okay, you were supposed to, sweetheart. Well, that's fine. As long as you've got the calculated version, I don't mind not having the steps. As long as you've got the calculated version. Yeah. All right. So here we've got 5.5 multiplied by 1.1. Oh gosh, I don't know what that is.
Here, I have it over here.
Can you check it? Pardon?
6.05. Or 9 cents.
Oh, no, I don't want the final answer.
6.05.
It is 6.05, so 5.5 multiplied by 1.1. And then we've got 10 to the 7 multiplied by 10 to the 4, 10 to the 11. And then 6.05 multiplied by 10 to the 11. Now, the reason I said I don't want the final answer is because sometimes this part here does not give you a number between 1 and 10. That's the numbers, they're the questions we're going to go on to in a second.
Okay, so you know how you put in decimal? I thought it's going to round, like how you...
No, so we don't round things unless the question asks us to. Okay, so we put all of the digits that are there, we write them in. Now, if your number has got 20 digits, then you perhaps would round it. But these are very straightforward, so we would put all the digits in. Okay? Next one here, 2.6 multiplied by 3.1. 8.06, thank you. And then we've got 10 to the 9 multiplied by 10 to the 5, which is 10 to the 14. So it's 8.06 multiplied by 10 to the 14. Okay? So everyone should have all 4 of those. Even if you've just got the final answer, that's fine because it will mean you did it in your calculator. Okay. Right, okay, now it says what happens if the coefficient is more than 10? And so these are the kinds of questions that start to get a little bit trickier but not lost. Okay? So here's our example, 6 multiplied by 10 to the 3, and then 4 multiplied by 10 to the 4. So the normal rules, we would multiply our two numbers, 6 multiplied by 4, and then we would add our powers and get 7. And we would be very happy with ourselves to say, there we go, that's our answer.
That's tricky.
No, well, it's tricky because is this in standard form?
Well,
Why not? It doesn't have a decimal point, exactly. Is this number here between 1 and 10?
no.
No, it's more than that, okay? So whilst it looks like it's in standard form, and often a question might trick you to thinking, oh yes, great, I've done it right, I've finished, move on. It's not in standard form because this number here is not between 1 and 10, okay? So we have to change it slightly. So how would I change this number to be between 1 and 10?
Yes, do you maybe, since there's 2 tens here, move down to more in the box?
Well, at the moment it's 24, so how can I make it a number between 1 and 10? Yes, that's exactly what we do. We're going to put a decimal point in between them, yes? Okay, so it's gone from being 24 to being 2.4, okay? But we can't then say that it's 2.4 times 10 to the power 7, because this was to the power 7, so this can't be to the power 7. So we have to think about what's happened.
8, right?
It is going to be 8, because what's happened is that I have changed this number to be a smaller one. Okay, because I moved my decimal point. And so that means that my power here has got to increase by 1.
It's not that tricky.
It's not that tricky, but some people get it.
What about if
Hang on. You go up. Exactly. So this is now going to be 8. Now, as Madison just said, if for example, we had 243 multiplied by 10 to the 7th. We need to change this number here. We'd have to move it 2 places. So this would be 2.43 multiplied by 10 to the 9 because we had to move it 2 places. Yes?
Is there any possible way by doing that you'll get a negative power?
Sometimes, but not often.
Oh, it was already negative.
Yes.
Okay. So basically, you just gotta, they wouldn't just keep that with thing. Like, they would just give you the beginning bit, tell you to like times it.
Well, they would ask you to calculate this. Now, well, let's practice in our calculator. Let's type the 6 times 10 to the 3 multiplied by 4 times 10 to the 4. Now, it's very likely your calculator may give you the whole number, so just be aware. So let's just check. So 6 times 10 to the 3 multiplied by 4 times 10 to the 4. Chuck it in your calculator.
224 times.
So it does actually give you it with lots of zeros.
Yeah. And then you just have to.
And you have to then know how to change
It
it.
has 7 zeros on it.
That's right. Okay, so your calculator gives it to you like this. You have to then change it to be standard forms. Okay. Now, for some of you, if you think, oh, I want to change it to standard form, you may prefer to actually use the short method by doing the 6 times 4 and then adding your powers. Okay. So whilst you have your calculator to help you, it's not always the fastest way of doing it because you still have to change this into the proper standard form. Okay?
Let's say the things that are negative and then you have to put 1 with that mean you have to go right and
You would be adding 1 on so you would become less negative.
Miss Harrison.
Yes?
And the power is more than 10.
Yes.
Just making sure.
Alright, so let's have a go at some of these questions then. Okay, so we can use I would suggest let's use our calculators for the first part. So, someone tell me what 9.2 multiplied by 3.1 is. We'll do at least 1 or 2 together. 28.52. Thank you. So 28.52 multiplied by 10, and then what do we do with our powers? We add them. So what's 4 plus 5? 9. Okay. So far so good. That's our first step. What do we do now, Maya? Move the decimal, so I'm going to write. Good girl. 2.852. And then what happens? 10 to the power of 10. Good girl, because we had to add 1 to it. So, actually, having our calculator to just do the first bit is probably easier than trying to do it all on the calculator, do you think?
Yeah.
Alright.
What do the next?
So, do you want to have a go at the next few, and then we can check them together?
Or
Right, well, some of you are finishing off.
10.
You can count me out. What's 4.5 multiplied by 4.2? So that would be times 10 to the 13.
Wait, why is it 18? 8 times.
And then we're going to change this to be 1.89
Oh,
multiplied by 10 to the power 14, because we had to add 1 off.
Can we just give you the plain answer if we...
No, I don't want you to, I want to go through the workings. So if you wrote just the plain answer, that's fine.
Okay.
But I want to go through the workings, okay? So 7.11 multiplied by 3,
21, 21.33.
and then multiplied by 10, and we add up the 30. Oh, lovely. And then we have to change this.
6.133 to the power 14.
Oh, I'm loving it.
I like fruit.
4, 9, 6, 7, 6,
Okay, I can't hear.
4,
5,
5,
9.76.
What?
J, I thought it was 4.
5,
It's 5.76 multiplied by 10 to the power of 8.
Thank you. Oh, cheapers.
And then 5.976 times 10 to the power of 9.
Okay, beautiful. We've got the stuff, haven't we?
Yeah.
and listening skills and reading out, not always someone's forte. Between us, we were a bit rubbish there.
Because people are viewers, it just like, oh god.
No, so let's have a quick look here. So these are going to the ones with the negative numbers. As I said earlier, the rule is just the same. So we've got 3 multiplied by 2
Is 6.
is 6. And then we've got multiplied by 10 to the power, and we're going to add negative 6 plus negative 4 exactly as negative 10. Beautiful.
So it goes down. You don't like do 6 plus 4.
No, because it's negative 6 plus negative 4. So if we're starting at negative 6 and we're adding on negative, so when we're adding a negative, it's the same as taking it away, yes? So you're going more to the negative, you're getting colder.
You don't do negative 6.
No.
Oh, I got the same answer on my calculator.
Because remember, we're adding, so that's what happens. The rule is you add your powers. Yes. Unless you divide. So 5 multiplied by 1 is 5. Multiplied by 10 to the power negative 9.
No, it's negative 4. No,
No, it's not.
5, negative 5 minus 4.
Thank you. And then 5.5 multiplied by 4.2.
23.1.
23.1 multiplied by 10 to the power. So this is negative 7 plus 4. So it gives us negative 3. Okay. But is this in standard form? No. So we're going to do 2.31. Now you've got to be careful here, because what did we always do to the other power? We added 1, yes? So this is going to go from negative 3 to negative 2. Okay? No, sweetheart, we are adding 1. Okay? But it becomes less negative. Yeah? So the rule is the same, you've just got to be really careful with those negative ones that you're getting the right answer. Now, I've got some practice for you for other questions. Some of them are dividing, okay, so you can just chuck them into your calculator, but obviously instead of a multiplying between the numbers, you're going to use the divide button. And I've got a couple of questions with adding and subtracting. Again, just use your calculator. I'm not going to go through non-calculated methods with you. You can just put them into your calculator.
The last, how did you get the negative on the 2 for the last one?
Because it was negative 3, because we had negative 7 plus 4. So if you start at negative 7, you add 4, you get to negative 3. And then we had to add 1 to it, so it became negative 2.
Okay.
Alright? So, then I can do it.